Hello guys, let's welcome to our channel Just Genius. In the last video, we have completed theta notation. With the theta notation, we have completed all the asymptotic notations also. So just recall these asymptotic notations once again. So let us start our video now. So what do this all means? So when you look into this one, f of n equal to theta of g of n. What do this theta means? Theta notation is used in average bound conditions, means average case scenarios. So f of n, g of n grows at same time. Same time means it is used in average bound condition. Okay. So when f of n equal to big O of g of n and not big omega of g of n, then we say f of n is asymptotically slower growing time. Means big O notation is used in upper bound scenarios. This is average bound. Big O notation is used in upper bound scenarios. In the upper bound scenarios, it is used in worst case conditions. Worst case, worst case scenarios, because worst case means it takes more time. The time complexity is increases in worst case scenario. Okay, so then f of n becomes slower growing than g of n. So that's why we can write f of n less than or equal to c into g of n. Okay, here we write c1 into g of n less than or equal to f of n less than or equal to c2 into g of n. Okay, so when you look into this, f of n equal to big omega of g of n and not big O of g of n. So okay, observe this definition carefully. F of n is asymptotically fast growing than g of n. Okay, because it is used in best case scenario, best case. So also in lower bound conditions. So we can write f of n greater than or equal to c into g of n. Okay, understand? So why they are given not equal to means, so if they are equal, it becomes average case scenarios, means it becomes theta notation. Okay, they have mentioned each and everything clearly. So not equal to, observe, follow this each and every instructions properly. Okay, so I hope you understand, you have understood these 3 points. So why do we use these notations? So majorly facts that you have to know about this one. To express the efficiency of algorithms, 3 notations must be used. So 3 notations. What are these 3 notations? Big O notations, big omega notation, and theta notation. These 3 notations are used. As scientists generally like express algorithms as big O notation, since we would like to know upper bound for learning. So majorly we will use big O notation because time complexity is always calculated in worst case scenarios. So if you know worst case scenarios, it is easy to know the best case scenarios also, So time complexity is also calculated in worst case scenarios. Remember this point. If they ask one bit like that, when the time complexity, in which case the time complexity is calculated, always worst case scenarios. Okay, if you know worst case, then we have to improve and avoid. Okay, I have told, if you know the worst case, it is easy to calculate best case and we can improve it to a further levels so that we can get the best time complexity. Our aim is to find the time complexity. Our aim is to find the time complexity in worst case so that we can aim it to improve. We can improve it one and avoid it. Okay. So why to study these 3 notations means because of this, because of the time complexity, because of calculating this time complexity. Mainly I have made really 3-4 lectures on these big O notations only, because big O notation is mainly used in calculation of time complexity. So please watch the big O notation once. Okay. So next, performance classification. So I have told you. So performance classifications, I have given an order. One less than, that order is this: 1 less than, log n less than, n less than, n log n less than. So what this classification can be done here. You can read this classification. It is simple only. You can just read. It is not easy to explain. You can read it. So constant, 1 means it is a constant. Log n means logarithmic. N means linear functions to majorly used. N log n, once steady, when n doubles, runtime slightly more than the doubles. Common in programs which break a problem down into smaller problems, sub problems, solve them independently and then combine, merge. So you have to divide that problem into some basic steps and divide that problem into steps. Suppose one problem is given like this, a problem. So divide this problem, also divide this problem, divide. Finally merge all of these problems and you will get an answer that is nothing but n log n. Okay. So that is nothing but n log n. N square, it is nothing but a quadratic function. You can write any, if you substitute any value of the n, you can get only positive values. n cube also it a runtime increases. Okay, and 2 power n exponential is very, you can see, we may not use 2 power n sometimes. Most probably answers we will get only in n or n square, some like in less case we will get answer in 2 power n. So it is an exponential. This is often related to brute force solution. So brute force means, before any introduction to the algorithms we have discussed brute force algorithm. So we have not discussed, we have mentioned in the coming videos we will discuss this algorithms also. So just remember this is a brute force. Okay, this is an order. How 2 power n is 2 power n is high input then non polynomial. Okay, remember this one. So just read it and just remember. Not only I am not able so just remember, not to by heart, just remember this one. Okay, with this we have completed completely about performance classification and also asymptotic notations. In the coming lectures we will start time complexity. Okay, thank you. The each and every materials of the data structures and algorithms will be available in the description box. You can access the drive link from the description box. If you like this video, please like, share and subscribe. Also one point, I have mentioned a Google form in the description box. It takes less than 10 seconds to fill up that form. Only one question has asked, how my teaching rates you. So give a rating to my teaching. If you like this video, please like, share and subscribe. So I make sure that you will give a rating to my teaching. Okay, thank you.